All right, hello everyone. Welcome to the first part of the video for section 1.2. Digging in some more with different properties of functions, and in this case we'll start talking about something called domain and range for a function. All right, so get right to it. Domain and range, what are these? Now normally if we're in class I would ask you guys to help me brainstorm, but unfortunately I don't have that opportunity right now. So I will just tell you then, the domain of a function is the set of all possible inputs to a function. Okay, and I'm sorry that may be hard to read, but again, it says a set of all possible inputs to a function. So all the things we're allowed to put into a function, which we did some practice with that in our prereq stuff. So if the domain is a set of all possible inputs, what would you suppose that the range is? Right, it's going to be the set, there we go, of all possible outputs to a function. All right, so domain is inputs, range is outputs. Okay, and the reason, or one of the reasons we want to study this is because it's often important to think about what are a reasonable domain and range for a function, what makes sense to input into the function, and what also makes sense to come out as outputs to the function. Okay, so here's an example we're going to look at, and in this example, I'll tell you we don't have a formula for this function we're going to look at. Will just be just kind of, it's one of those more theoretical functions. So we're letting f here be a function relating the age of a person to their heights. So as an example, or what we mean by that is f of age in years. So notice the ages here are the inputs. So we input someone's age and that outputs their height. Now again, there's not a formula for this. It's just if you input a particular person's age, you get an output of a height. So an example of this, I'm sorry, I'm gonna have to clear all this out, is someone on this video who may be the person talking right now is 33 years old. So to figure out their height, we could do f of 33, and it would output that person's height in inches, which that person is about 5'9½", which in inches is 69.5. So inputting 33, the age of 33, for this particular person gave us an output of 69.5 inches. And just again to reiterate what this means, this is the height, or sorry, that's not the height, that's the age. So this is why it's important to identify these things. That's the age, which are the inputs. Okay, and then the height here, that's the output. All right, so with that in mind, let's think about what a reasonable domain and range, or what would be reasonable to use as inputs and outputs here. So first of all, does it make sense to do f of 12? Would it be reasonable to input 12 to this function? Hopefully you're saying yes, right? Because there are people out there in the world who are 12 years old, so it makes sense to input a 12-year-old's age and find the height. Does f of 92 make sense? So does it make sense to input 92? Well, that's a little less common, but I think yes, there are people that are the age of 92, right? So we could input 92 and output the height of a 92-year-old. What about f of 245? Does that make sense? Hopefully you are shaking your head right now. Okay, so that yes is for the first one. So f of 245 does not make sense, right? Because there are not people, as far as we know, in the world who are 245 years old. So that one would not make sense as an input to the function. Okay. All right. Let's look now at outputs for the function. So would it make sense to solve something like f of age equals 62? And let's think about what's going on here, right? They have not given us the age in this case. That's the input. But they've given us the output as 62 inches. So does it make sense to solve for the age of someone who is 62 inches tall? Well, yeah, because 62 inches is about 5 feet 2 inches, and there are plenty of people in the world that are that tall. What about, would it make sense to solve f of age equals 240 inches? Well, 240 inches, how tall would that be? Well, let's see, there's 12 inches in a foot, so 240 inches, this means this person would have to be about 20 feet tall, right? So does it make sense to find the age of someone who's 20 feet tall? Well, hopefully, again, you're saying no, because in this case, there are not people that are that tall, right? That's an unreasonable height. So we would not have, that one does not make sense to solve. So that's be something that's not, whoops, not in the range of this function. Okay. All right, so let's think about then what a reasonable domain and range would be. Okay, so for our domain, right, that's our set of all possible inputs. So if we're talking about ages and years, what would be kind of the highest and lowest values we could have there? Well, what's the lowest age someone could be? Hopefully we generally agree that could be like a newborn baby, right? So maybe someone who just came out of the womb would be about 0 minutes old or 0 years old. And the oldest someone might be, I think from reports I've seen, is that there are people who are 113 years old. Okay. So that would be like kind of our highest, maybe even 118. And since these represent ages, I'm going to put a variable here to represent that. So I'm going to let A represent the ages. So in this case, we'd have our domain, our values of A, or ages that are between 0 and 113. And I have 0 less than or equal to A, less than or equal to 113, because there are people whose ages are 0 years old or 113 years old, right? So those ones would be included. All right, what about range now? So this is now looking at the heights. And I'm going to use the variable h to represent heights now. So what's like the shortest anyone could be? Well, we again had to think about babies and how long are babies. Well, I know some premature babies can be pretty small, maybe like 8 to 12 inches. Maybe we'll say 12 inches. Any of you who are parents out there can correct me on that. Maybe that should be a little bit lower. And what's about the tallest someone might ever be? Maybe like 8 feet tall? Sure. So 8 feet tall, that's about 96 inches. So it looks like our values of h are between 12 and 96. And again, it could be either of those, so put equal to signs there. So our range, it looks like, would be 12 is less than or equal to h, which is less than or equal to 96. Okay, and that would be our domain and range of this particular function that relates age and height. Okay. All right. So let's talk about some other ways to write domains and ranges. So I'm again going to write these off to the side. The domain we came up with there, whoops, sorry about that. The domain we had was, let's see, 0 is less than or equal to A, which is less than or equal to, what did I have? Like 113, I think. And the range we had, what did we say? We said 12 is less than or equal to h, which is less than or equal to 96. Okay, so those are written in as we saw in our prereq work, those were inequality notation for domain and range, right? Well, let's look at some other ways to write this. So we can also write this in what is called set builder notation. Okay, and set builder notation is actually very similar to inequality notation, just a little bit of extra stuff you need. So when you write something in set builder notation, the way you do that is you first of all start with a curly bracket, and then we put our variable. So in this case, if we're doing the domain, we would put an A there. And then we put this big vertical line, which that big vertical line there, that means such that. Okay, and then we just input that inequality. 0 less than or equal to A, which is less than or equal to 113. All right. And the way this is read, again, is A, that's what the A means there. So A, ages such that 0 is less than or equal to the ages, which is less than or equal to 113. So it's kind of like a longer way of writing out the inequality with a few more details. All right, if we do a similar thing then with the range with our heights, when we do set builder notation, again, do curly brackets, do a 12, or sorry, not a 12, an H, since that is our variable. Big line such that, and then that inequality. 12 is less than or equal to H, which is less than or equal to 96. Okay, and that would be set builder notation. All right, and then the other thing we'll relate this to is interval notation, which we have already done some work with. So hopefully that won't be too difficult for us. So if we're going to do this in interval notation, then the way that'll work. Okay, well, again, we have compound inequalities here, so we have numbers at each ends. So we can just write our interval notation by using those. So do 0, 113 for the top one, 12, 96 for the range. And then notice in each of these cases, they all have equal signs on the inequalities, which tells us we put brackets around them. So our domain would be bracket 0, 113 bracket. Our range would be bracket 12, 96 bracket. Okay. All right, and I really like this this chart here because it shows the relationships between inequality notation, set builder notation, and interval notation very nicely. So notice on the left there, you see something in inequality notation like this one here, and you see it in set builder, and then you can see how that relates to interval notation. So notice here, we have a 5 and a 10, so those are our two endpoints here. With the 5, it's just less than, no equal to sign, so that's just a parenthesis. And then with the 10, it's a less than or equal to, so that's why we have the bracket here. Okay, so that gives us parenthesis 5, 10 bracket. And you can see how that works with the other ones. You can also see how with these ones lower down, like h less than 10 or h greater than or equal to 10, how those relate to writing interval notation, right? So h less than 10 means 10 and everything below it, or sorry, not including 10, but everything below it, right? So that's why you have that negative infinity to 10, because negative infinity is the lowest possible thing you could be below 10. And then for h greater than or equal to 10, so here they start at 10, have a bracket because you're starting there, and then going up to positive infinity. Finally, there will be times when your domain or range will have no restrictions. And so in cases like that, your domain or range is actually all real numbers, which when you see this fancy looking R, that's generally what we mean by that. And all real numbers means we can be as low as possible or as high as possible. So that's where we get this negative infinity to infinity interval notation here. Okay. All right, I think I'll leave it there for right now. Thank you for watching.